In this video, we'll go over the homework that follows the lecture 10.3 that explores the possible ways to handle this pattern, one of which is inverse trigonometric substitution. As always, I hope you watched this lecture, and let's go ahead and jump right into the homework. And the first problem is a definite integral from 0 to 1. The idea is simple. When you see a pattern like this, or rather like this, so there are multiple ways to express this pattern, right? So you can see it either like this, or you can have it reversed like this. In our case, we have 4 squared x squared plus 576 is 24. So this is like our thought bubble, and we're going to do the following substitution. In this substitution, we're going to choose x to be 24 over 4 tangent theta, and 24 over 4 is 6, so we have 6 tangent theta, so that dx becomes 6 secant squared theta d theta, and the square root of 16x squared plus 576 becomes just a 24 secant theta. And other things that we have to consider, we need to consider the change of limits, and before we change the limits, we have to acknowledge that two facts: tangent theta will be equal to x over 6, meaning that theta will be equal to arc tangent of x over 6, meaning if you want to change the limits of integration, which is normally recommended, when x is equal to 0, you're going to have arctan of 0, which is 0, but when x is equal to 1, you're going to end up with arctan of 1 over 6. And we've seen it before. Normally you don't need reference triangles, but in these problems you may. So we can draw out a reference triangle here for angle theta. And here we have hypotenuse. So this is my hypotenuse, this is opposite, this is adjacent, and tangent being the opposite over adjacent means this is x, this is 6, and this will be the square root of x squared plus 36. And now with all this prep, we're ready to do substitution. So we continue with the original integral. And my original integral now becomes an integral from 0 to arc tan of 1/6, and we have 1 over 24 secant theta, and there we have dx is 6 secant squared theta d theta. So 6 and 24 cancel, secants cancel, so cleaning up this integral gives us 0 to arc tan of 1/6. 1/4 is outside, and the integral of secant theta is well known. So we have 1/4 ln of secant theta plus tangent theta. We plug in 0 and arctan, we have secant of 0 is, so we're plugging everything in, right? So we have secant of arctan of 1/6 plus tan of arctan of 1/6 minus 1/4 secant of 0 plus tan of 0. So tan of 0 is 0, secant of 0 is 1, ln of 1 is 0. So we don't have to worry about the second part of this expression, but we still need to figure out secant of arctan, and, well, tan of arctan of 1/6 is just 1/6. But what is the secant of arctan? Secant of arctan, so secant of arctan of x of 1/6 is going to be equal to secant of theta, but when x is equal to 1. And secant of theta, according to this reference triangle, is equal to secant is what? Hypotenuse over adjacent, so it's going to be a square root of 1 squared plus 36 over 1, so it's just going to be a square root of 37. And we're dividing by adjacent, so here goes 6. Square root of 37 over 6. That should be the final answer. So let me plug it in. And let's move on. Number 2. The difference is that now we have indefinite integral. And but the pattern that we recognize is the same. In our case, we have 4 squared plus 12 squared x squared. And the substitution that's going to work is x equals 12 over 4 tangent theta. So that dx is equal to 3 secant squared theta d theta. Square root of 16 plus 144 x squared is just 12 secant theta. And we're also going to express tangent theta as x over 3, which means the reference triangle will look like this. So opposite side is x, the adjacent side is 3, so the hypotenuse is x squared, square root of x squared plus 9. And because it's an indefinite integral, we don't have to worry about the limits. And this integral now becomes this. We still have an integral, but now we have 1 over 12 secant theta times dx, which is 3 secant squared theta d theta, which is 1/4 integral of secant theta d theta, and it's a well-known integral, so it's 1/4 ln of secant theta plus tangent theta, but plus c. But we need to go back to the original variable, so instead of secant theta, we use the reference triangle, and for secant theta we write hypotenuse over adjacent, and for tangent theta we write x over 3. And that's the final answer. It's better being plus c thing, but now I'm a little paranoid. So plus c I mean, the only way to check is to actually graph it. So now that I wasted one attempt, I'm gonna graph my derivative, my original function. Right, this is my antiderivative, supposedly. We have here over x plus square root of x squared plus 9 divided by 3. So that's my function. And again, doesn't like the absolute value. So let's put parentheses here. For when x is positive, that's what it looks like. Now what I'm going to do is I'm going to graph the integrand. This is the integrand. And we're now going to, like, the derivative of our supposed antiderivative should be equal to the integrand. And it's not. So where did I go wrong? What's the derivative of integral of secant? Did I? Can't seem to find the mistake here. Let's see. Substitution is fine. So 3 tangent. Oh no. Oh boy. Rookie's mistake. Happens a lot, right? So here the substitution should be actually 4 over 12, not 12 over 4. So I don't know how. I mean, I know how I missed it, but something that you cannot miss. So we have here, we have it's going to be 3x, and this is therefore going to be 4. So we're going to have tangent theta is just 3x over 1. So this is 3x, this is 1. So this is square root of 9x squared plus 1. And then this is 4. This is 1/3. So this is 1/12. So we have 1/12. It's 1/12. Tangent will be 3x, and secant will be square root of 9x squared plus 1. So that was the mistake. And now we're going to double check everything. So we're going to remove this. We're going to put 9 over here, 1 over here, 3x over here, 1 over 12 over here. And we're gonna, so the derivative, so the red should match the black, and now it is. So this is the right answer. Great. So it wasn't plus C. It was me being completely wrong. But I'm still gonna put plus C. Is it the absolute value now? It has to be. And that's what happens when you don't put the absolute values and do the wrong substitution. So, lesson learned. Let's continue. The pattern here is that we have a squared plus b squared x squared. We have 2025 is, it's 45. So we have 45 squared plus 5 squared x squared. That means the substitution is x equals 45 over 5 tangent theta. So it's going to be 9 tangent theta. So dx will be 9 secant squared theta d theta, square root of 25 plus 25x squared will be equal to 45 secant theta. And since tangent theta is equal to x over 9, and its opposite over adjacent, my reference triangle will look like this. And the hypotenuse is 81 plus x squared, square root. Now we're ready to do the substitution. my integral now becomes this. And simplifying, we have 1/5 integral of secant theta d theta, which is now 1/5 ln of absolute value of secant theta plus tangent theta plus c. Secant theta is, according to the reference triangle, it's hypotenuse over adjacent, and tangent is x over 9. I want to try something. So what if I don't put plus c? Will it count? It counts. Not sure why. Okay, 3, 4. I have integral square root 81x squared plus 5184. And the pattern here again is if we have b squared x squared plus a squared, which is what we have, 5184, 72. So my substitution is x equals 72 over 9 tangent theta. So 72 over 9 is just 8. Dx is equal to 8 secant squared theta d theta. Square root of 81x squared plus 5184 is going to be 72 secant theta, and tangent theta can be expressed as x over 8, which is opposite over adjacent. Reference triangle then will look somewhat like this: opposite, hypotenuse, adjacent, 8x square root of 64 plus x squared. And now we're ready to do the substitution. So this integral becomes this. We have 72 secant theta times 8 secant squared theta d theta. 72 times 8 is 576. Integral of secant cube theta d theta. And I think we did integral of secant cube earlier, so it's going to be 576 1/2 secant x tangent x plus 1/2 ln of secant, and I don't have x, I have theta. So 576 is what? What is 576? What did I get? 576. 72 times 8, and then we divide it by 2, so it's 288. And now we have secant theta. It's the hypotenuse over adjacent, so it's square root of 64 plus x squared over 8 times tangent, which is x over 8, plus I already factored 1/2, so here we have ln of square root of 64 plus x squared divided by 8 plus x divided by 8 plus c. And that's the answer. Let's type it up. And we finished this homework. If you have any questions about how to do this particular inverse trigonometric substitution, please feel free to reach out.